Welcome back to another lesson for Math 8, lesson 117. So after today, 3 more lessons and we're done with the lessons at least. You still would have a couple tests and the end of course exam. But yeah, so we're going to end somewhere in May. Yay! So today we're going to do lesson 117, which is significant digits. And so I'm going to try to teach this lesson in the book because I don't think I need the board a lot. But if I do need the board, I'll let you know. So let's actually get into the lesson. Yay! Okay, so to start off this segment here, we need to know what significant digits are. And so your book says it right here. Yeah, I moved the book too much. It says the number of digits we use to express a measure with confidence is called the number of significant digits. Yes? Yes. So what they're trying to say is that significant digits are what we usually use to say that confidently, yes, that's the answer that you should get around and stuff like this. By the way, disclaimer, significant digits is more useful for science than math, but we all know that math is the only exact science. So yeah, there we go. But significant digits is usually for chemistry or physics or some math like that. Some science like that. Anyway, they have 6 rules, and I thought it would be easier for me to go over them in the book than write them down. So the first thing is that you have to count all non-zero digits. So any digit that is not 0, as it says right here, count all non-zero digits, you have to count it. So 2.54 has 3 significant digits because it has 3 non-zero digits. What is the second rule? It says count zeros between non-zero digits. So if there's a 0 in between numbers that are not 0, you have to count it. Like, for example, here they have 10.7, right? 10.7 has 3 significant digits because it's 10.7. 1 and 7 are non-zero digits, and so that would be significant digits right there. 3, because the 0 is between 2 of them. The third one is counting trailing zeros in a decimal number. The decimal 1.20 has 3 significant digits. The reason it has 3 significant digits is because we actually went out of our way to write the 0 after the 0.2. So 0.20 would be 3 significant digits. Number 4, do not count zeros if there is not a non-zero digit to the left. So when do we not count zeros? We start with the fourth rule, and it says the number 0.023 has 2 significant digits because we know that 2 and 3 are not 0, right? Are non-zero digits. And the other ones are kind of like placeholders, 0.0. So we only say 2 significant digits. 5, trailing zeros of whole numbers are ambiguous, meaning ambiguous means that it could either be significant or they cannot be significant. It's up to you. The number of significant digits in 1,200 might be 2, 3, or 4. Expressing a number in scientific notation removes ambiguity. Yeah, that's how you say that word, ambiguity. And the number 1.20 times 10 cubed means that it has 3 significant digits because it has it right there, 1.20. And 6, exact numbers have an unlimited number of significant figures. So we do not count any digits when dealing with exact numbers. Exact numbers includes counts and exact conversion rates like 3 feet equals 1 yard and 2.54 centimeters. So exact numbers are the measurements that we've been learning for conversion rates. Okay, those are exact numbers, and so it has unlimited potential. It's over 9,000. No, it's just unlimited stuff. So let's look at example 1 because I don't want to write that on the board. It's just mostly letters and stuff like that. So it says A, the diameter of a quarter is about 2.5 centimeters. Obviously, they put 2.5. It's just 2 numbers, so the answer is 2. Duh. Then it says the ruler is about 30.5 centimeters long. 30.5, well, the 0 is in between 3 and 5, so it's counts, so it'd be 3. Oh, look at that, 3. Earth's average distance from the sun is about 9.3 times 10 to the 7th miles. Because it's 9.3 and then 10 to the 7th, we know it's 2. And then a mile is 5,280 feet because that is an exact conversion rate. It is unlimited potential because it's exact. Yay. All right. Yes. So before we move on, I'm going to actually give you some bonus right now. The bonus for today is pretty easy. So for those of you who want to comment down below, let me see where my hand is. Below, yes, below the YouTube comments, you can actually put your favorite movie. What's your favorite movie? And I know there's a lot of different movies that you might like. So the one that you like right now the most. For me, it would be too hard. I don't really have a favorite movie. I love a lot of movies, so that's hard. And then so that's the first 5 people that do that. And for those on Google Classroom, you have to put, obviously after 5 people have put it on YouTube, the next 3 people, you just have to put what's your favorite snack. All right, what's your favorite snack? So for YouTube, favorite movie, 5 people. For Google Classroom, what's your favorite snack? 3 people, and that's it. All right, let's move on. All right. So before we move into the board, I just wanted to read that little rectangle part that it's been rectangled, or put in a rectangle, I guess, so that you understand what it means. It says a product or quotient of 2 measurements may only have many significant digits as a measurement with the least number of significant digits. So all that says, it's a mumbo jumbo for saying that if you have 2 numbers that are being multiplied or divided, and one of them has 2 significant digits and the other one has 5 significant digits, the answer has to have 2 significant digits, because you're always going to go with the least amount of significant digits or numbers. And that's it. That's pretty much it. So let's actually move on to the examples. Okay, so in here I'm going to do 2 examples at once. And the first one, it says, well, example 2, obviously not the first examples. The first part, it says, at the beginning of the lesson, we're not supposed to be touching our faces. Okay. There you go. Nobody saw that. All right. So we're 8.9 divided by 4, right? So we're supposed to do that because the first segment that they showed you is 8.9, right? So 8.9 and then divided by 4. So we have 2, 8, then 2 again, 8. Then 2 minus 8, 2, 5. Yay! So I got 2.225. $8.225, yes. 2.225, sorry. So I got 2.225, and yet that's not the right answer because we have to do it by significant digits. Again, you only have to do this if we ask you to do significant digits, not every time. So, because significant digits here are 2, and some people are going to be like, wait a second, what about 4? 4 is an exact number. An exact number also means whole numbers. Whole numbers are exact numbers because 4 is 4, right? So 4 has an unlimited power. Unlimited. I was going to say infinite, but unlimited sounds better. So because it has unlimited, we have to go with 2. And 2 would be this. Obviously, you would have to round it up if you could, but then it would be 2.2. Yay! So you understand, right? Because 4 is an exact number. It has unlimited power. Unlimited! Like the unlimited data that some of your plants have. All right. And then in example 2, we have 1.2 millimeters in a cube. And then we have to find the volume of a cube. The volume of a cube is going to be side cubed. We have to cube the side. So to cube the side, we're going to have 1.2 cubed. 1.2 cubed is 1728. And because it has, I think it's 1728 or 1827. 1728. I know this because it's 12 squared. 144 times 12 would be 1,728. And so because we have 3 decimals, where are the 3 decimals? 1 decimal, 2 decimals, 3 decimals, 1.728 millimeters cubed. So once we know that, we have the answer. However, how many significant digits? We can only have 2 significant digits. So my answer would be 1.7 millimeters cubed. All right, let's move on to another example. Okay, so the last example. I know there's a little rectangle before that, but what it's going to tell you is what I'm going to show you here, which is pretty easy. So we have 6.24 divided by 4.6. You have to line up the decimal numbers, right, and put a 0 here. And 4 minus 0 is 4. This becomes a 12. This becomes a 5. 12 minus 6 is 8, not 7. Oh, no, it's 6. It's 6. What am I talking about? It's 6, sorry. And then 5 minus 4 is 1. 1.64. However, milliliters. However, what they're going to tell you there is that you have to use the significant digits of the least amount, and we have 4.6, not 4.60. We have 4.6, and we only had 2 significant digits, so the significant digits would be 1.6 milliliters, and voila. Je suis fini. That's it. I am done. This is it for lesson 117. 3 more lessons to go. Woohoo!